So, hello guys. Function notation. We're starting a new chapter, which is functions. It's going to be a big one, not just like trig. Also quite challenging. Arguably, when I look at it now, I wish I did this lesson towards the end of trig, because I know it could have helped you. But you know, this is a learning process. We're learning together. So I know you struggled, okay, when we had to draw graphs or get information from graphs when I have things like f of 2. What does this f of 2 mean? So this really lesson is about that and a little bit more. So what is a function? Okay, those who are taught grade 8, 9, how it works. What is a function? It's remember?
Oh, so like you put something on
Oh, yeah.
Yeah, remember, what did I do, Luano? I'll say it. I'm not going to embarrass you, all right? It's a machine. A function is a machine, okay? It's a machine. You put in a certain number, let's say a number 1, and then it goes, right? And it spits another number, 2, let's say, okay?
I remember that.
All right, remember that one? Hello. Let me just pause here. Yes, young lady. Right. Right. So, guys, a function is a machine that takes a bunch of numbers, 1, let's say 5, 7, and each number it processes, it goes as and turn into another number. Okay, let's say like that. Right? Then we know, okay, remember in prep school even, okay, or at least in beginning grade 8, 9, we use these tables. Do you remember these tables?
Yes,
okay, so we said, okay, when x is 1, y is 2. When x is 5, okay, y is 6.
And then we
When
do the
x is
t and
7.
stuff again.
Yeah. Okay? Right? Yeah, well, yeah, but sometimes it's more complicated. We will look at easy bits. Now it could be more complicated. And then, all right, all I'm saying now is like this, okay? Because you still remember in trig, okay? Oh, sorry, let me just go back a bit. Sorry, just go back. Then when we did that, what did we used to do now in the graph? We would plot it, right?
Yes, sir.
Okay, so we put all these points, 1 and 2, let's say, 5 and 6, 7 and 9, and then maybe we draw a line. Normally I think we only work with straight line. But as we will see now, sometimes it will be curvy. Okay? And we also call that function, we would call it like this, y equal, let's say, 2x plus 3. We had something for it. Okay? Now we're introducing another way of writing it. And maybe before I show you, I'll explain why. Okay? So in trig, okay, maybe let's just pause and get rid of some stuff here to make it more. So as you saw really towards the end of a trig, we had sometimes 2 graphs on the same axes. And it's going to be difficult for us to say y equal, I don't know what, sine x plus 2, y equal minus cosine x minus 1. I'm just making it up. It's not the same as that. Why is this going to be a problem if I use this writing it like that?
Because it's just not going to make sense.
Well, we won't know which one is which, right? It's not easily like which one is this y or is this the y? You have 2 graphs. So now we're going to write it using this notation. So instead of writing y equals sine x plus 2, we can say f of x equals sine x plus 2. And I can say, oh, let's say this is f. It's not really, but let's say it is, okay? And then I can write, if this is the f, then let's call the other one, let's say g. And then I can say g of x is equal minus cosine x minus 1. Do you understand? But it's the same thing. It's just this is a specific machine, okay, which we call f of x, which is equal to sine x plus 2. And if we put a certain number here, let's say 0, okay, it will spit out another number, okay? And for now you can use calculators, but it will come easier. Sine of 0, anyone remember what sine of 0 is?
It's like 1.
0.
It's actually 0, okay? So plus 2, it will be 2. So if you put in 0, 2 comes out, okay? If I put in, let's say 90, what is sine 90?
0.
That is 0.
9.
Did I make a mistake? Sorry, sine 90 is 1. Plus 2 will be 3. Okay? So we're just using this notation. Okay? Let's just pause and I'll get rid of that and we'll go to the example. I've looked, I do question by question. Right, so guys, we just need to clarify it. It is dead easy, but because it's your first time, it might be a little bit confusing. When I say f of 2, what do I mean?
X equals 2.
X equal to, it doesn't mean f times 2. Okay? It basically means, and I'll write it down here, it means the value of f, the value of this function when x equals 2. It's like writing, I don't know if this makes it more clear, f of x when x is equal to. But we never write it like that. Okay? Maybe I'll write it down on the other side. Okay? When x is equal to 2, we find the value of x. So how do I know that? Using, if I know what this function is. Now we have a specific function. But I substitute. So we're going to 3 times 2 squared minus 1.
4 minus 1.
It's chill. 4 times, how much?
11.
11, right? 4 times 3, 12 minus 1, 11. No? Hang on. Well, let's do one more. Let's do one more. Okay? Okay. What is f of minus 3? It's not f time minus 3. It just basically means that x now is equal to minus 3. So I'm going to, instead of x, I'm going to substitute minus 3.
But you put the minus 3 in brackets, right?
I must put it in brackets. You're absolutely right. So it's 3 times minus 3 in brackets squared minus 1. Let's do it slowly.
26.
Okay, let's do it slowly. Okay, it's 3 times, what is minus 3 squared? 9. Minus 1. You're right, it is 26. Okay, I'll pause here to make sure we're happy with that. So far, so good, easy. Now, this is still easy, but it's going to be a little bit confusing. Okay? So, what is f of a? What is x equal? X equal a. Whatever a is, we don't know what it is. It doesn't matter. What are we going to substitute instead of x here? A. So actually it's really easy. It's going to be 3a squared minus 1. That's the answer. We don't know what a is, but we just substituted it. Okay? Alright? I'll tell you something now. Hopefully it will make sense. Okay? X is what we call a variable. What is a variable? It's something that varies. Varies means change. It's something that can change. Okay, we can put 1, we can put 2, we can put minus 3, we can put minus 5,000. A is what we call a parameter. It's something that can't change. It's fixed. I don't know what it is, but it's just fixed. Okay? That's it doesn't can't change. It can't change. Just whatever it is. A, we don't know what it is. Okay? Let's pause. Let's not pause. Let's carry on with something even trickier. But not difficult. What is f of 3x?
Substitute it.
Okay? You see what we're doing? Every time, we're just taking that number or letter, or in this case, a number and a letter, and we're substituting in the rule. This is our rule. This is our E-O machine. So, what does this rule, please, Henkel, okay? What does this machine tell us? He said, take a number, whatever number you have, square it, because we're doing bod mass, right? We're starting with squaring, then time it by 3, and then minus 1, okay? So if I have 3x, what do I need to do to that 3x?
Put it in brackets and then
put it in brackets,
the
square it, then time it by
3 and then
3 and minus 1. And then we just use normal simple algebra. It's easy, right? Okay, it's 3 times, what is 3x squared?
So it's 9x.
9x squared minus 1. What should I do now?
So you do the multiplication.
Okay, so 3 times 9?
27.
27x squared minus 1. That's it. That's it. It's easy, isn't it?
Okay,
let's pause. Right, guys, so the last bit, and maybe the trickiest, but you're still going to do it. They'll ask you, they're not going to tell you f of something, they'll tell you find x if f of x is equal to 2. Yes. So you want to find x now, not f of something. Leo, what do you reckon?
I would say you put 2 equal 3 point everything there.
Very good. So what Leo says, okay, I don't know what x is, but I know that f of x is equal to 2. So I'm going to put, instead of f of x, I'm going to put 2 equal 3x squared minus 1.
And then move over.
And then we can solve that. We learn how to solve these things, right? Okay? Well, there's, the way I showed you is move everything to one side so we have 0 on the other side. That's what we call a quadratic equation, right? So it's going to be 3x squared minus 3. Yes, you're right, because we
Equals
minusing
zero.
the 2.
Equals
Okay,
0.
equals 0. What should we do now?
Move
Common
the.
plus three.
You can take a common factor or just divide by 3, but we'll go the long way around. Okay, let's write it here. So we're going to take 3. X squared minus 1 equals 0. At this point, come on, let's get rid of that 3. It's doing nothing for us. So we divide by 3.
Still 0.
X squared minus 1 equals 0. How do we solve that?
Difference of the square.
Yes. Now you could do what you said. We could add the 1 there, but there is a risk there. I told you I really recommend factorizes. And this is the difference of a square. How are we going to factorize it?
X plus 1.
X plus 1 times
X
minus 1 equal to 0. Now we have two solutions. The first solution is
X equals
X equals plus 1.
negative 1 and the other one?
X equals
plus
plus 1.
1.
That's it. Now what was the problem with adding the 1 here? Okay.
Here about two solutions.
That's it. You square root that, you probably will get 1. You'll forget you'll lose that minus 1. Unless you remember that when you square root a number, you'll get the plus and the minus. So I'd rather you go that way. Okay? Right, that's it. Let's do some work.
Yes, please.